In this video, we're going to look at applying the Pythagorean theorem to help us solve for missing side lengths in three-dimensional figures. And this is a perfect segue for our next topic, which will be finding volume of these three-dimensional figures. So if you look at the two that we have here, we have a pyramid and a cone, and they're very similar. A cone is like the circular base of a pyramid. And what to point out that you'll see in these next couple of examples is there's two heights going on. So if you look, they each have this straight up and down height, almost inside of each of them. And we call that the vertical distance from the top to the base is just our normal height. And a lot of times we'll use h. Okay? This fancy word here, apex, is the point on these types of 3D figures. Just kind of a more you know situation. We also have a different height as well in each of these, which is on the surface of the side. So if you look, a cone has one and a pyramid has one, and that lateral surface distance is called the slant height. And we'll use an S for that. Okay? So you might even be all ready to tell from my picture that we're starting to form a triangle when we look at those two heights. So if I have the straight up and down height and the slant height, this part right here would help me connect and make a right triangle. So I would have my 90-degree angle there. This slant height here would be like my hypotenuse, or C. The regular height here. And then whatever half of our base would be. So we're going to look at how to use those three side lengths and the Pythagorean theorem to help you solve for missing values. So in our first example, we're going to find the height, and here we have a cone. So finding the height of a cone. So a little throwback for you with this word of radius. Remember, radius is half the distance on a circle from the outside there to that middle point. So my radius of my cone would be this side length right here on the inside of that base. And it's telling me that that's 14 centimeters. And then I have the slant height is 28 centimeters. So the slant height is here. It's that surface diagonal height, and that is 28 centimeters. So here it wants us to find the height, so that inside, that straight vertical distance from the top to the bottom. So that's what I'm looking for. I can call it h for height, or if I'm thinking in terms of Pythagorean theorem, a squared plus b squared equals c squared, this 28 would be my c, and then I could use either 14 as my a or my b. So maybe I'll call this a and this b. So my Pythagorean theorem states that a squared plus b squared equals c squared. If I look at what I currently have, I called my height a, so I don't yet know a, but my b value comes from the radius of my cone. So here I would put in 14 squared. And then c would be that diagonal slant height, so I have 28 squared for c squared. So next would be actually calculating what each of those things are. So 14 squared gives me 196. 28 squared gives me 784. So to start to work to get a by itself, I first would need to subtract 196 from each side. So 784 minus 196 gives me 588. And remember, I'm not quite finished because that's a squared, and I need to get rid of that square, so the inverse would be to square root. And let's see what that gives me. Ooh, not pretty. I'll round to the hundredths, but I got 24.25 if we round. So that's telling me my vertical height would be 24.25 centimeters if my slant height is 28 and my radius is 14. That makes sense because remember, the hypotenuse has to be your longest side, so it couldn't be any higher than 28, so I think that looks pretty good. Next, we're going to look at a similar example. This time we're going to be finding the slant height, and we have a pyramid instead of a cone. Okay? So it first says the base of the pyramid is a square with side lengths of 30 inches. So what that's telling me is kind of around the outside of this, we have 30 inches of a square. So each side here would be 30 inches. Okay? If you look, that's not really going to help me as far as that inside triangle. I need this distance here, which isn't going to be the full 30 inches. Instead, it's going to be half of it. So we couldn't say something like a radius for this problem because a square doesn't have one. So a lot of times they're going to give you that full distance and you'll have to remember you're only going to use half of it. So if the side length is 30, that means that piece that I need is really 15. So that's where I'm going to go from that 30 inches. Okay. Then it says the height of the pyramid is 50. So that inside vertical height here is 50 inches. And this time it wants to know what's the slant height. There's a lot going on in this picture. I might even just kind of redraw it off to the side to help me. So I have 50 here, 15 here, and I want to know what is that hypotenuse or the slant height. Okay, so you can call 50 and 15 either A or B. Remember those two, you can mix them up how you want. So A squared plus B squared equals C squared. Let's say 50 is A and 15 is B. So I would start by plugging those in. So 50 squared plus 15 squared, and I don't know C. So C would be my slant height, and I don't know what that is yet. So 50 squared gives me 2,500. 15 squared gets me 225. And together, those would be C squared. So let's see, I'm going to end up having 2,725, and that's what I'm going to need to square root. And let's see, also not pretty, if I stick to my hundredths, it would be 52.20 would be my slant height here. So 52.2 or 52.20 inches would be my slant height. So notice, if you want the slant height, you're looking for the hypotenuse. So there I'd be finding C. In the last example, I was just looking for the height, and there that would be either A or B that I'm looking for, not C.